In this last objective for the section, we want to talk about the difference between correlation and causation. One of the big abuses, if you will, of correlation is the misunderstood belief that when two variables show correlation, it must mean that one variable, a change in one of the variable, causes a change in the second variable. So changes in the explanatory variable cause changes in the response variable. This is true in some instances, and it's not true in other instances. For example, according to data obtained from the Statistical Abstract of the United States, the correlation between the percentage of the female population with a bachelor's degree and the percentage of births to unmarried mothers since 1990 is 0.940. That's a very, very high correlation between the two variables. It's very, very close to 1. But would it be reasonable to say that the higher the percentage of the female population with a bachelor's degree, the higher the percentage of births to unmarried mothers? So suppose a politician got up in front of cameras and said, I want to decrease the percentage of births to unmarried women. Therefore, I am going to decrease the number of women that get a bachelor's degree. Would this be a good idea, and would it be an effective policy?
No.
Why not? All right, we'll take a different tact. Certainly a politician would not say something to that effect because of the fact that it's not likely the case that the level of education that females have is in any way a direct cause of the percentage of births to unmarried mothers. Agreed?
Agreed.
The reason that that correlation exists the way it does is because this is what's called time series data. We collected the data annually since 1990. It just happens to be the case that during that span of time, both variables happen to be moving in the same direction. It happened to be the case that since 1990, consistently a higher percentage of the female population was getting a bachelor's degree. It also happened to be the case that in 1990, the percentage of births to unmarried mothers has been on the rise. It has nothing to do with the fact that the two variables are related. They just happen to both be moving in the same direction over that particular time frame. The bottom line is this: if you collect data that's from an observational study and you have correlation between the two variables in that study, you cannot claim there is a causal relation between the two variables. You can only claim causality when the data are collected through a designed experiment. We saw in the drilling data that there was a linear relation between the two variables. Was that data collected through a designed experiment?
Yes.
Yes, it was. So does the depth at which you start drilling cause an increase in the time it takes to drill an additional 5 feet?
Yes.
Yes, it does, because again, it is a designed experiment. All right, let's look at another example. Sometimes we've seen in observational studies that two variables are related to each other not because there's a causal relation between the two variables, but rather because there's a third variable lurking in the background. Remember, a lurking variable is a variable related to both the explanatory and response variables. So, for example, it turns out that ice cream sales and crime rates have a very high positive correlation. Does this mean that we should shut down all ice cream vendors in an effort to reduce crime rates? No. What do you think the lurking variable is?
Temperature.
Yeah, the warmer it is outside, the more your ice cream sales you're going to have. the warmer the temperature is outside, the more crime you're going to have as well. It's very rare to have a robber running around your yard when it's 10 below outside. This is example 5 from the textbook. I'll read this scenario to you. Because colas tend to replace healthier beverages and colas contain caffeine and phosphoric acid, researchers Catherine Tucker and Associates wanted to know whether consumption of cola is associated with lower bone mineral density in women. So the data that you see there in table 3 represent the typical number of cans of soda consumed in a week and the bone mineral density in the neck region for a sample of 15 women. The data were collected through a prospective cohort study. Can you remind me what that means? What does prospective mean?
Future.
Yeah, what they did is they identified these 15 women at a point in time, and then going forward, collected data from the women. So they probably had to fill out a survey. How many cans of soda did you consume each week for a certain amount of time? And then at the end of the study, the researchers measured the bone mineral density of these women. And in that way, they were able to collect the data shown. Figure 7 shows a scatter diagram of the data. What does that scatter diagram imply about the relationship between number of colas consumed and bone mineral density? As the number of cans of cola goes up, what happens to bone mineral density?
It goes down.
It appears to go down. So we would say this is a negative association between the two variables, yes? In fact, the correlation between the two variables is negative 0.806. From table 2, we find that the critical value for n equals 15 is 0.514. So because the absolute value of negative 0.806 is bigger than 0.514, there is, in fact, a negative linear relation between the two variables. Are you with me so far? Can the authors conclude that by increasing cola consumption, that causes a decrease in bone mineral density? Does this data conclude that there's a causal relation between the two variables?
Yes.
How many say yes? Close your eyes. We don't want to be influenced by our peers here. How many say yes, causal relation? How many say no, not a causal relation? All right, open your eyes. For those of you that said yes, why do you think there's a causal relation?
Well, the numbers show that as Cokes increase, that your bone mineral decreases. So
The numbers do show that as the number of Cokes consumed increases, the bone mineral density decreases. I would suggest to you that if I had shown the scatter diagrams of the percentage of the female population with a bachelor's degree and percentage of female population with first unmarried mothers, that would also show clearly that as one goes up, so does the other. All right? How is this data collected? A cohort study. Is a cohort study a designed experiment or an observational study? These are observational studies. All we did with these women is ask them over the course of time, how many colas did you consume? And then at the end of the study, we measured their bone mineral density. Was there in any way, shape, or form an attempt to influence the value of the response variable, bone mineral density? There was no attempt whatsoever to influence or directly impose a treatment upon the women in the study. We allowed them to decide on their own how many colas they consumed. Did we try and control for any other variables that may impact bone mineral density? Can you think of some variables that may also impact bone mineral density? Age? Smoking, perhaps? Physical activity? Another one that was actually cited by the researchers, I believe I have it on the next slide, is consumption of calcium. Oftentimes, cola will be a substitute for a drink that might have more calcium in it. And so, because of that substitution effect, there's less intake of calcium. So there's a lot of variables out there that were not necessarily accounted for in the study that, or controlled at least in the study, that may impact bone mineral density. Agree? The bottom line is this: because this is an observational study, we cannot say that number of colas consumed causes a change in bone mineral density. We can only say that the variables are associated. So saying that the variables are associated is not as strong of a conviction as saying that one causes the other. Bottom line again, when you have observational studies, you can say that two variables are associated with each other. You cannot say that one causes a change in the other. So again, this is an observational study, so we cannot claim causality. There are some lurking variables in the study. Body mass index was one, height, whether the individual smokes was mentioned, alcohol consumption, calcium intake, physical activity. You folks mentioned a couple of these. Again, even though, you can use some advanced statistics to account for these variables, because no doubt the researchers, as part of their survey, weekly survey, did ask things such as this, or were able to measure things such as this. And even after accounting for those variables, you can still only say that the variables total consumption and bone mineral density are associated. You cannot claim causation. The only way you can do causation is literally design an experiment and force people to drink a certain amount of cola each week. But again, I think there are ethical issues there. If you suspect that increased cola consumption causes a decrease in bone mineral density, would you feel okay in forcing people to consume 8 colas a week, knowing that you might be reducing their bone mineral density? Probably not. That kind of interesting? A little bit? So I'm telling you, when you read it in the media, the first thing you have to look for is, how was this data collected? Did I press resume?